Hi everyone. Today we are going to talking about the module 4 in the course of the design of reinforced concrete elements. So few classes we have discussed about the module 1, 2, 3. In module 1, I described about the basic fundamental concepts of the design of reinforced concrete structures using the working stress method, limit state method, and ultimate load method. Both we have seen the pros and cons of the three different methods. Then analyze the singly reinforcement and doubly reinforcement using the walking stress method as well as the limit state method. We are briefly discussed in the module 1. While coming to the module 2, we are discussed about the flanged beams, this analysis the design of the T beams and L beams, and as well as the shear forces and torsion be acting on the structural members we are discussed. In case in the module 3, we are elaborately discussed about the different type of the slabs and for a different type of the staircases. Is there including the one-way slab and two-way slab, cantilever slab and continuous slab and different type of the staircases. Exclusively for we are discussed analysis the design of the dogleg staircases. In continuous with the this module 3, now we are going to discuss about the module 4, design of columns. Here we are going to discuss about the different type of the columns and how the behavior of the columns and how to design the columns for our construction practices. So that's we are going to discuss about in the module 4. Okay, so module 4, detail we are going to discuss about the limited design of the columns. Here we are going to discuss about the various type of the columns and design of the short rectangular columns for the both bendings, axial bending, uniaxial bending, and biaxial bending. As well as now then we are going to discuss about the short column for a circular column for axial, uniaxial, and biaxial bending. That we are going to discuss about this module 4. So, what is the main objective of this module 4? We are going to see about the as a learner you need to understand the different type of the columns what you are using in practical field. That so it's the classification is mainly is based on the whether it be a short column or be a long column and be a tied column or a spiral column. So mainly it be classification. Then we can able to classification based on the shape, which may be a rectangular shape or be a circular shape or be L shaped or be a T shaped. We can able to classify the columns. These are the columns. As a learner should know how to be classify the columns. Okay, that we are going to implement in the field of civil engineering. Then learner to know the how the behavior of the short columns. Okay, already we seen two type of the column, one be a short column and be a long column. Here students should learn the how the behavior of the short column, especially for the load carrying capacity of the column. Then what is the failure of the mode of the failure for the in the short column that students should be learned. Then students we are going to learn about the study of the column under the axial as well as the eccentrical loadings. When you're taking see the column, we have two type of the loading will be act normally the axial load and the eccentrical loads. Okay, what is it be axial load? Axial load acts through the centroid, that will be a CG of the column, and eccentric load will be cause the bending and the stressful variation will be going to be occur. Okay, so that we need to look at into the detail into the forthcoming slides. Then students should know about the analysis of the uniaxial as well as the biaxial bending of the column. What is the uniaxial bending? Both any one of the axis column going to bend it, that you having eccentricity will be there. Then biaxial bending about the both axis for x-axis as well as the y-axis, the beam column going to be active. Two movement will be generated. Then finally, last the objective of this module 4 is design the RC column as per the Indian standards code book. Okay, so we need to design the analysis of a rectangular, it be a circular column, and we need to design the reinforcement dating as per the IS Six. Okay. So now we see some of the images we have included here, different type of the column and failure column and various types of the loading. Both will be axial and uniaxial and biaxial bending, how it will be occur. Based on the loading, you need to provide the reinforcement. It be a rectangular reinforcement or a column reinforcement. That everything we can able to do. First, we need to understand that column predominantly taking the compression as well as the bending. So, as we are, while considering the design of the column structure, we need to do the proper analysis and ensure the safety as well as the performance of the structure. So, once if the design is over, we need to, as per code, good detailing and adhering the as per S456, ensuring the durability and performance of the structure. So, this is the overall crush the module objective. Now, we are going to discuss the very elaborately and each and every objective. So first of all, we should know about what is meant by a column. If the column is be a vertical, it will predominantly it will take the compression member. Okay, it will load will be transfer to systematic the procedure. Okay, from slab. So it will be slab. From the slab, we are applying for the load. Both will be a dead load as well as the light load will be there. That slab load will be converted to the beam. Now the beam load is converted to the column. Then column load is converted to the foundation. This is a sequence of the load transfer mechanism. This will be there. Okay. What we need to understand theoretically, the column is mainly the load carrying capacity of the element. Okay. That holds the structure. It be a safety. So column is a main important element of the any of the structure. Okay, the column only going to support for the above the beam and the slab like that. No, from the ground floor to the top floor, the entire system will be a main prominent. The main role of the column is the only for structural elements. Okay, how we are classifying the types of the column, the based on the shape. So based on the our requirement, we can able to do for a lot of the shape. So normally two type of the column we can able to see. One is for a rectangular column and it's a square column. It'd be very easy. If a form work is very easy, so we can able to make a construction very easy, both for a rectangle as well as the square column. Most of the building, if you go there, see the colleges and schools and apartments are anywhere. This two type of the column it will be you can able to see easily. Is rectangle as well as the square column. Then other column for architectural purposes, mainly for the bridges and other things, we can able to use for a circular column. Then this is two mainly commonly used. And other than we can able to polygon shape and other shape we can able to make this is based on our customer requirement. Then based on the reinforcement, needs to be a tied column, or we can able to do for the spiral column. What's the tie? It's be a tying the main reinforcement. Long-term bars we are going to face. That is be a lateral ties. The hold the bars in the position. It be most common. Okay, when you started pouring the concrete, when you started to apply load, the long-term reinforcement is coming out. For that, we need to resist. So we are going to use for the tie holding the for main reinforcement. Okay. Then spiral column. The spiral column mainly we are using for the circular column. The spiral reinforcement provides better confinement for the circular column. So these two cases, based on the reinforcement, we can use for this type of the column. Based on the loading system, we can able to divide the three types of the column. One is for the axial loaded column, uniaxial loaded column, and biaxial bending of the column. What is the axial loaded column? The load is acting on the CG. So here the axial loaded column eccentricity equal to be 0. So load acts on the axis of the column. Okay, so both axis, x-axis and y-axis eccentricity equal to p0. Next column is uniaxial bending of the column. What is uniaxial bending? Uni means what? Okay, any one direction, either it be x direction or y direction, load will be acted, the moment will be generated. So load action within the eccentric causes of the bending will be acted. Then what is in the biaxial bending of the column? Load acts with the eccentricity in the two direction. In both the direction, the load will be acting. Then moment will be generated. Those type of the column is called biaxial column. Okay, listener. So normally we can classify the three types of the three types based on the shape, based on the reinforcement, and based on the loading system. Okay. So what are the key future, when you're using the different type of the column, if you see the summary of the table, what we discussed in the design of the column, or the on basis by using the by shape, we can use for the rectangular shape, we can use for the square shape. Normally, common type of the all the shape we can use for buildings. It will be used in the building systems. If you're using the circular column, it will be a round shape, the uniform in the plane. So we can use it for aesthetic structures and bridges. We can use it for a circular column. Based on the reinforcement, we having a two type of the reinforcement. We discussed on the tied column and the spiral column. So, what is a tied column? Lateral ties hold the bars. The spiral column, the spiral gives the better the confinement. So most of the building we can use it for the by reinforcement column. So mainly the spiral column of the reinforcement we can use it for high-rise buildings, seismic zones. They're having more maybe confinement will be there. Need to taken care. So for those type of the building we can use for based on the load only, the axial load along the axis. So where we are using the more compressor load will be acting, there we can use it for axial loaded column. Uniaxial bending, a load with eccentrically is a bending in any one direction. It will face edge of the column and the frames. With the corner of the column is most of the time is facing the uniaxial bending. Then biaxial bending, a load with eccentricity in the two direction, both direction, the corner or irregular shape of the structure. Okay, that we can able to see in the biaxial bending of the columns. So here the practical example is seen where we are using for the rectangular column, and then where we are using for the circular column, tied column, spiral reinforcement column. So three type of the column loading system will be failure also is seen on the axial loaded column, uniaxial loaded column, and biaxial loaded column. These are the practical example. Yes, different type of the column. So what we need to understand that the columns are vertical compression members. That load will be a transfer from the slab to the beam and to the foundation. So ensure the stability and safety, the entire structure, the column is the most important element in our concrete structure. Okay. First of all, we need to understand what is the meaning by short as well as the long column. What is the short column? In the height, the name itself, we can see the height of the column is very, very less. Does not buckle, but it will take the crush. So we can say the short column fails due to the crushing of the column. How to classify based on the numerical value? That means h by b, height divided by width of the column is less than or equal to 10. Then we can say for the short column. In case a long column is a failure predominantly for the buckling because the height is more. When you apply the load, it will be started to the buckle. So how we can say the h by b, height to the width of the greater equal to 20, greater than 20, we can classify it as a long column. So how the behavior naturally it will happen for the behavior of the short column under the load. Now we know concrete will take compression and steel also will be taking compression here because now it's if you see earlier module we discussed about the steel won't take the any compression while coming to the column, steel also will be taking into the concept for compression. When you're seeing the images, for see the column, both are composite material, steel as well as the concrete, then applied the load. Okay, when you're applying the load, the concrete also will be taking the compression and the steel also taking the for the compression here. So now what will be is a composite member, both work will be together. Okay. What is the mode of the failure in the short column? It will be only for crushing of the concrete will happen. Then welding of the bars. This is two is only possible of the failure because two material will be there. If you see the diagram, the crushing of the concrete, the failure I have seen as well as the welding of the bars. Okay, will be. So two in a short column, the failure in the two mode of the failure. Here, what we are doing to avoid the bulging, okay, failure of the longitudinal members, we are going to provide for the ties. Okay, what is the role of the ties? They prevent the buckling of the longitudinal parts and hold the concrete core. Okay, it won't give up for the concrete. So ties act like a cage to hold the column together. So Now it will be a farm work, then reinforcement. The reinforcement, the tie going to place to be hold, okay, like a cage. So short column are safe from the bulking, but can fail by the crushing of the column. Ties to keep the core or bars to be together. The column having a different shape and different type of typing and a different loading system. Then how the design we are designing the axial loaded column. In concept, if you see a load actually to be centroid, that means the E equal to 0, eccentricity will be 0, no bending, only compression will be at. So both concrete as well as the steel, it will take for the compression load. Okay. So uniform compression over the section from the top to bottom, all the energy will take for the compression tension. Here we won't take the any tension. Both concrete as well as steel will take the compression radio. So when you behavior is such that we can able to find out how much load is acting, then we can able to find out the movement, then we can able to provide the reinforcement. So longitudinal reinforcement we can able to provide in the vertical direction, and lateral ties that also we can able to provide to hold the longitudinal bar as well as the concrete. Okay, so perfect axial loading is rare in the rare life. We cannot. While talking about the practically, it is very difficult to make the axial load of the column. You can see for any one of the side, bending will be occur when you in the x direction or y direction, any one direction, the bending moment will occur. That's why saying the axial load making the structure is very, very complicated. Okay. So here, when you axial loaded column will be a typical reinforcement details. If you see the vertical bar will be longitudinal bars will be vertical, and lateral ties we can call it for the stirrups. So ties hold the longitudinal bars and the concrete core will be together. Now you see the third images to show the practical example. Columns carrying a load for the beams and slabs directly to the foundation. So behavior under load for the axial loaded column, the entire structure will be a compression going to take. It won't take the any tension. So neutral axis always act in the center. That's why we are saying the axial loaded column. So the entire section it will take for the decompression. So when you started to apply the load, it be an axial loader. In other cases, now see the under uniaxial, any one direction, the load going to act, there we need to causes for the bending. Real concept of the uniaxial bending, load is eccentric in a one direction. So it will be causes compression on one side and reduce the compressive or the tension on the other side, because uniaxial then automatically will reduce the compressive area and will be increasing the tension other sides. So neutral axis is not in the center, far away from the load. The one side heavily compressed because of this axial load. So column behaves like a beam, then column will be combined for the under biaxial bending. So now we see the images for the bending about the one axis. So if a load is acting on the away from the center, now we're forming for E eccentricity. The neutral axis also be reduced. Here if you see compression stresses will be high, then tension are be reduced for the compression in the other side. So this is behind the principles of the uniaxial bending. So section under the bending, the compression on the left, the compression side will be automatically be reduced. Okay, the neutral axis also will be changed. When you use load is acting on the uniaxial, the practical example is the eccentric load from the beam, the framing the cast bending in the column, it shows in the finger. So when if you are designing the uniaxial bending practically, the effect is the uniaxial load is increasing the compression on the other side. Then other side we can say for reducing the compressive forces and the tensile forces we started to increasing. So reduction in the compression or tension on the other side will be created. So neutral axis shift toward the tension side. Then high movement or deflection will be occur because of the accessibility loading. So now we can able to compare the two type of the loading system, one is uniaxial as well as the axial loaded column. So load condition, the axial load column is the load is acting on the center of the gravity. The load is acting on the one direction, the uniaxial bending. When you're bending, if you say the axial load column, no bending, that's why we are saying the eccentricity equal to 0. So here, the uniaxial bending causes the bending in the one direction. So while talking about the stress distribution, the uniform compression and throughout of the structure in the axial load column. While coming to the uniaxial bending, the compression on the one side and other side, the compression is reduced or tension shorted to for the uniaxial bending. The neutral axis at the center is not a critical. So because the load is acting on the center. But here not like that for uniaxial bending, the shifted towards the tensile side. So typical behavior of the structure in the axial load column, entire section will be a compression. But here the one side is heavily compressed and other side will be for the tensile side. So design note, provide the longitudinal bars plus ties we are already using. So need more steel because of the uniaxial, then ties on the tensile side we need to provide. So columns are designed to safety carry loads and moments. So proper reinforcement and detailing we can able to achieve for ensure the strength and stability and safety of the structure. Then other type of the column is called biaxial bending. What is a biaxial? Bi means with two. Load is acting on the two direction. So two eccentricities will be formed. One is x direction as well as the y direction. The moment also will be generated in the two directions. So what is the concept of the biaxial bending? The load is eccentric in both directions about the x as well as the y axis. So bending about the two axes simultaneously will be occur. So column practically experienced both will be compression, bending about the two perpendicular axis. So when you design biaxial bending, how it will be behavior, the more complex stresses distribution across this section. Okay, in case of the axial load column, no stress distribution, everything will be compression only. Uniaxial bending, one side is having a more stress distribution in compression and other side will be reduced. But in biaxial bending, the more stress distribution across this section, the compression varies in the both direction. When you look into the images, okay, when you see the color shows the different stress distribution in the stress section area. Okay, then high compression will be shows with the red color, then compression, then low compression, then neutral zone, and bit tension. Here bit tension is very less. So stress distribution varies across of this section, both under x and y directions. So if you see here, the practical example shows all the corner column in the engaged with the biaxial bending. Corner column, so column in the irregular building also, you can able to face the biaxial bending. How biaxial bending should be occur if the load does not pass through the center in the plan, as be essentially both direction and ex and ey. So because of this load, the moment also be caused in the both direction x and y. So how to calculate the moment in x direction equal to load into eccentricity in the y direction, and my that is moment in y direction, load into eccentricity in the x direction. We can able to count moment in x direction and moment in y direction. Based on the moment we can able to provide for the reinforcement. So next, this is a typical stress distribution on both x direction and x and y direction. So here compression as well as the tension and neutral axis changes, everything you can see. So based on the moment, we can able to design the reinforcement detail CB also. What are the design consideration when you are designing the biaxial bending? Check the strength under the biaxial bending. You can able to see SP16 available, that is called interaction diagram, or we can use for the design code, and provide the adequate longitudinal reinforcement, and closely we need to space for the ties for the confinement. Okay, so consider the second order effect will be in case of the center columns. So now see the practical example how the closely spaced side better the confinement to failure of the biaxial loaded column. You see the summary for a biaxial bending, a load condition, a load is acting on the both direction, x and y direction. Bending also will take the two perpendicular axis both x and y axis. So stress distribution, the complex varying across the section in the two-dimensional. So neutral axis will be a curved, shifted both the direction, not in the uniform. The typical location, corner of the column, and irregular building we can see for the biaxial bending of the column. How to design approach? We can able to use for interaction diagram and code provision. We can able to design the biaxial bending of the column. We see the practical images where we can able to face the biaxial bending of the columns. The beam framing of the two perpendicular direction, ascending load on the both axes will be occurred. So this is called the biaxial loaded column. So what is the key line? The biaxial bending is the most realistic to the cases in the actual structure. So good design and ensure safety under the complex loading condition, we can able to avoid and failure for the biaxial loaded column. So rectangular column, in we are designing how to design the rectangular column. So where first of all we are using the for rectangular column, all the commonly we can able to see all the building. Normally we can use for rectangular column. Why? Because of the formwork is very easy. Normally the making the formwork for rectangular column is very easy and fits very well in the wall. Wall thickness will be very okay. So reinforcement arrangement also very easy. The bars are placed in the corner for longitudinal reinforcement along the side bars. Then we can use it for the ties to holding the longitudinal reinforcement. So placing of the bars at the corners and along the sides ensure the better confinement as well as the strength within column. So how the behavior of a rectangular column based on the under the axial load, uniform compression is occurring, under a bending, stress variation will be there. This already we discussed in the previous slides. So what are the design consideration when the designing of the rectangular column? So minimum eccentricity always should be considered. So we cannot omit always be equal to zeros. Certain minimum eccentricity will be there. That based on the code we can give for the minimum eccentricity, and also proper spacing between the ties and the reinforcement bar we need to keep. Then adequate the cover. The cover is important for the column, that we need to give the proper adequate cover as per the IS 456. Okay. Now, normally, what is the minimum eccentricity given? The tie spacing, if you minimum less than or minimum equal to 16 mm diameter or 300 mm. So, minimum cover as per code 25 to 50 mm. Minimum eccentricity equal to L by the 500, but not greater than less than equal to 20 mm as per the IS code. So here see the practical example, common building corners on the beam framing, the columns in the irregular bending. Okay, rectangle columns provide flexibility in the layout. Okay, where using this rectangular column, easy formwork and twists in the wall for easy to the work. Reinforcement bars are providing along the side sets. So behavior, it may be axial load, uniform compression will occur, and sometimes it causes for the pure bending stress variation also. Okay, so when you are designing the consideration, we need to see the for a minimum eccentricity we need to allow, and proper tie spacing and adequate cover also we need to provide. So application, the corners and irregular building we can see for the regular of the column. So these are the reinforcement details for the rectangular column. Okay. Good practice is check out when you are going to the field. What are the things we need to get and provide the bars at the corner along the sides are available. We need to check. Use close ties for the confinement. Then we can able to prevent the failing of the column. So maintain proper spacing of the all the ties. We need to adequate concrete cover and cover that be ensuring safety of the structure. Consider minimum eccentricity in rectangular design. So good rectangular column designed with the proper reinforcement and detailing performance and both axial as bending loads, we can able to safety of the our column. As usual, this next will be a circular column, wherein we use most probably we are using for the architectural structure for the circular column, and the bridges we can be able to use for the circular column. What is the main advantage when compared to the other column for a circular column? A same strength in the all the direction, because it will be a rectangular. In case of using the rectangular column or square column, we cannot able to say our strength is the throughout the section is uniform. But here we can able to say confidently if you are using the circular column, the strength in the all the directions. The better resistance will be biaxial bending. So there, if using the rectangular column or circular, it's probably possible for the biaxial bending in both directions. Now, using the circular column, we can able to see resistive for a biaxial bending. So more efficient under the eccentric loading system for a circular column. So it will be a reinforcement detail. We can use it for the circle longitudinal bars. So we can use the tile or that here when using the here, you can use it for the spiral reinforcement. So provide the confinement and the shear strength, you can use it for the columns. So behavior, the uniform stress distribution along the entire cross section of the column, more efficient under the ascending beam loadings. So axial loaded column, the load is acting on the center of the cavity. So what will happen is uniform compression in the all the directions. Okay. So now you see the load is extending, load is acting on the from eccentricity. The pressure will be high. We cannot able to maintain the uniform stress distribution. So compression is be higher on the one side and tension on the other side if you loading acting on the eccentricity column. So normally while designing of the circular column, we need to avoid the biaxial of the bending. What is the major difference for circular and rectangular column? Strength in the all the direction. Circular column means the strength will be all the direction, but rectangular column varies with the directions. So biaxial bending resistance, circular column is to be resisting biaxial bending, but in case of the rectangular column, it will be very lower to resist the biaxial bending. So efficiency under the eccentric loaded, the more efficient in the circular column, but in case of the rectangular column, is a less efficient. So stress distribution is a uniform in the circular column, but non-uniform in the rectangular columns. So if you see here stress distribution, the circular column will be uniform in the all the direction. Rectangular varies with the direction. Okay. What is the summary of the? You see the summary. The same strength in the all the directions. They perform equally well under the loads from the any direction in the circular column. A better resistance to the biaxial bending. The higher stability when the loads are acting in the two directions simultaneously. More efficient under the eccentric loading. Handles of the central loads better with less concentration of the chest. So ideal for the modern structure, we can use it for the circular column. So ideal for the modern structure, widely used in the bridges and architectural designs for safety purposes, we can use it for this type of the column. Okay. What is a practical example? Circular column is a bridges. We can use it for a circular column and architectural structures. So key line. So circular column performs better under multi-directional loads and eccentricity to be effect, making them the strong choice for modern type of the structure. Okay. When you're designing designing the concept, what is things will be there. So first one, we need to consider the importance of practical concept. We need to provide the design certain things in using the code book, the minimum eccentricity. If the load is axial, if the load is small also, for design purpose, we need to consider the minimum eccentricity as per mentioned in the IS code, because the preferred eccentric load is a very, very impossible in the practically. At least minimum eccentricity we can able to provide. The loads answer reality. Loads are never perfectly aligned. CG. Okay, so always cause some bending will be there. That's why we need to provide the minimum eccentricity. While talking about the ductility, still ensure the warning before the failure. So it will show the small cracks before failure. Prevent the sudden collapse for the column. Why eccentricity to be assumed? Axial will be centric load. Ideal cases, the impossible and the possible. That's why we need to give for minimum eccentricity as per provision provided by the IS code. Okay, the small eccentricity it will always be considered for while designing of the columns. So here we see the different type of the failure modes for the column. Okay, first is the crushing of the column, and second is a bulking of the reinforcement, and third one combined for the compression as well as the bending failure. When it will happen is the crushing of the column is the excess of the compression causes the concrete to be a crush. Okay, and second is the bulking of the reinforcement. The longitudinal bars buckle due to the instability. Okay, third one combined high compression and bending Okay, then column cannot able to resist, so it will leads to the failure of the column. So different type of the reinforcement already discussed. Longitudinal bars arranged in a circular form, so that is give the uniform strength for all the direction. So tiles or spiral reinforcement provide the confinement and enhance the ductility and prevents for buckling of the column. And behavior, if the loading acting on the CG, will get for uniform compression in the all the direction. Then in case of the having eccentricity, one side having a maximum stress will be there, another side will be a less compression or tension will be started. Now here see the final summary of the all different type of the column. If you take up the short column, it be axial, axial and uniaxial is any one side having a eccentricity, and biaxial load is acting on the both the direction, and circular column eccentricity any direction. Okay, one behavior in circular short column is the uniform compression, and uniaxial bending the one direction just varies to be linearly. On biaxial column is a behavior is bending about the two directions. Rectangular column bending varies with the direction will be there. Circular column uniform should be all of the direction. So where we can use main failure of the risk of the short column is crushing of the concrete. But in case of unicameral, not only crushing and also be bending failure will be in one direction. So biaxial column, the failure will be complex stress will be it will be vary from all the direction. Rectangular column purely bending in the bending failure. Circular column less prone to the bending failure. What's the advantages where we can able to use different type of the column, where having a high load carrying capacity, there we can use for the short column. Uniaxial bending simple and commonly used for the uniaxial bending. Biaxial suitable for the real structure. Rectangle column easy form work and fixed pivot and efficient for multi-direction load we can use it for the circular column. So what is a good practice to be checklist when you're going to the field? We need to check the minimum eccentricity we are provided or not for designing of the columns. Then provide the proper longitudinal reinforcement in the circular column. Use the closely spaced ties and spray confinement. Then main adequate concrete cover and follow the code requirement as per the SP6 chart and IS 456 for detailing for the reinforcement of the column. To ensure the ductile design to the avoid for brittle failure. So what we need to conclude for the column, the circular columns they perform better under the multi-story loads and eccentricity effects, making them the strong and efficient choice of the modern of the recent structure. Dear learners, as of now we discussed various type of the columns and behavior of the column and reinforcement detailing of the column. So hope you understand that now you can able to identify the different type of the column based on the shape. It be maybe a rectangular shape or circular shape or L shape or a T shape. Wherever you can see now you can able to classify the shape of the column. So based on the height you can easily say whether the column is be a short column or long column. Now and you can able to understand the cross section and the reinforcement arrangement, how the reinforcement providing for a different type of the column. Now you can able to understand the behavior of this short column, mainly for load carrying compression. It will take the more compression. Then it will take the small lateral deflection also be occur. Now you can say the failed by the crushing of the concrete, then higher load carrying capacity than the longer column. You can able to see for the short load axial loaded column. Now you can able to analyze the column under the axial as well as the uniaxial loads. The loads acting on the through the centroid, we can say for the axial load, the extended load causes the bending moment, and you can say how to calculate the stress variation across the section also. Now you can able to evaluate the both biaxial bending effects of the columns. So bending for the both principal axis, interaction for axial as well as the bending moment you can able to calculate. You can use the interaction as well as the IS code diagram for assessment evaluate the biaxial bending of the columns. Now you can analyze and design based on that you can able to provide the reinforcement for the columns. Okay, need to design ensure the IS course by the requirement. Now you can able to provide the longitudinal reinforcement ties or spirals. So we can If you do the proper, we can able to ensure the strength as well as the stability and ductility of the structures. So column, we need to understand overall outcome of this module. Columns predominantly resisting compression as well as the bending. So we need proper analysis, ensure the safety and the performance of the structure. If we do the proper good detailing and grants to the codes, ensure durability and stability of the structure. The column is a very pronounced structural element. While designing, we need to much take care designing of the columns. Okay, so this column chapter also it's available both the textbook design of reinforced concrete structures for IS 456 2000 for Krishna Raju and reinforced concrete design Unikrishan Pillai and Devraskan. You can able to refer those type of the textbook while the studying for examination and designing the practical example we can use for two textbooks. So dear learners, thank you for attention for the module 4. So very soon we are going to discuss about the module 5, that is the design of the footing. So thank you very much for the learners.